hear me? So what we can do first is I'll run through the setup and yeah, we'll start with that.
Okay. I'm good to go.
You ready?
Yeah.
Okay. Okay. So what we have here is, this is the 1 liter unit. You guys have the 2 liter unit at your facility. Operation is exactly the same. In order to run the machine, you have to have a power supply, which is a rectifier here. The rectifier hooks up by a positive and negative lead, also known as the anode lead and the cathode lead.
Okay.
They will hook to either the front of the machine or the back of the machine.
Okay.
And it's then wired to the back of the plating unit here. Once it's hooked to the back of the unit, it's sending power to each anode and cathode bar across the machine. Okay. You don't need to move any leads again once it's activated. Once you get to the unit, you'll notice some different controls. The first one on the top, this is your stirring device. So inside the bath, there's a magnetic pellet, a little white pellet. Okay. The speed of that pellet is controlled here. And this is what creates agitation in the bath, the movement, which you can see by looking down in here. Some baths have different requirement for movement. Some you want to move slow, and some you want a lot of agitation.
Okay.
We can generally find all that information on the tech charts. For example, here.
Okay.
On a tech chart, it's going to tell you everything from the concentrations of the metal, just information about the bath, but it's also going to tell you temperature, time, and what kind of agitation. And generally it'll say if it needs agitation, and it'll say mild, or if it needs aggressive agitation. Okay. But generally you're going to run this at about middle speed on the agitation. You can turn it off by turning it all the way to the left.
Okay.
And that will kill the speed. The light's always on whenever the unit's powered. The next set that you see here is the heat.
Okay.
Okay. Each one of these sections is unique to its own power supply, its own control panel, its own heater, and its own feedback thermocouple. So each one of these controls one bath, and that's the bath that's in the front of the unit. Okay. Okay. To change the temperature, it's as easy as pushing up or down. You're controlling the green button. The red color is reading the actual temperature of the bath. Okay. As long as those are not the same, it'll heat to reach this temperature. Or in the case that you set it below, now it's going to kill the power to that heating element.
Okay.
Okay. Each one of these temperatures will also be on the tech chart for the solution. On the top, you'll notice 3 bars.
Yep.
You have your anode bars, which are the ones attached to the red leads on the outside of the tank. These bars specifically are where you hang your anodes. In the 2 liter unit, I would recommend you have one on each side. Okay. Okay. This particular bath now is your degreasing or electrocleaning.
Okay.
So we have a stainless steel anode in the bath. For the 1 liter, we only need one, and that's what we'll run with today. The center bar is considered your cathode bar, and this is where you actually hang your piece.
Okay.
The circuit is closed when you have the anode submerged in the solution, and then the cathode is also submerged, attached to these bars. That's when you close the circuit. That's when you'll see amps show up on the rectifier. Okay. Also known as current density. Okay. It'll be referred to as current density in plating quite often. Right. Current density is dictated by the surface area of the part, the surface area of the anode, and the voltage that you apply to the bath. Okay. Each pod is designed to have a treatment tank and its own designated rinse. Okay? It's important that you do not cross the rinses. Okay? You're carrying drag out from here into that bath. If for some reason you came to the unit and you saw that the heater was not submerged all the way, or it was setting in the back tank because you rinsed it and it's not getting the feedback loop, you can quickly turn off the heat by hitting this button. That's your power. Okay?
Just for that one.
Exactly.
Okay.
My recommendation at the end of every day, turn these off so that there's no mistake of accidentally having the heater back here. Because then it'll just send full power because it's getting feedback from here that it's only maybe 75 degrees. And you'll burn up the heater and could damage the machine. A big advantage to these machines is everything's accessible. If something happened that a heater went bad, this just slides out and unplugs and you slide a new one in there. Or sorry, not a heater, a stir, and you slide a new one in there. If for some reason the heating module went out, this control panel, this just unsnaps, unplugs, you put another one in place. Each heater can be individually unplugged at this point. So you could unplug them, take them out, and rinse them. So you either can turn the power off at the end of the day or unplug each one. But I wouldn't leave the power on and this plugged in and then kill a master power, because then you do run that risk of burning up the unit. Okay? As far as sequence, the way we've laid out this machine now, we have degreasing, electrocleaning, we have the rinse. From here, we're going to degrease, rinse. We will then neutralize. Neutralizer doesn't need to be in the machine. It requires no heat and no electricity. Okay? We'll come in, we'll neutralize only for 10 seconds. Any time beyond 10 seconds, you begin to etch the surface. And you can cause problems. Some people like to be in there for a minute because maybe they heard that at some point, but it will cause problems. Earlier I mentioned hydrogen on the surface and the problems that that can cause. If you take a palladium-based alloy and white gold, for example, and go into degreasing and you're in there at too high a voltage or too long, and then you come into the neutralizer for too long, you create a hydrogen layer on the surface and you'll have a hard time getting adhesion with that part. So it's important to understand the substrate that you're plating as well. After we do neutralize and rinse, we're then going to go to thickness gold. Okay? The thickness gold has an efficiency rate and tells you on the tech charts how long to build 1 micron. How long do I need to be in that bath for 1 micron? So for example, on this bath, it tells you time of exposure can be anywhere from 30 seconds to 180 seconds. We're going to run this at 120 because at 2 minutes, we're going to build 1 micron. And we'll do that. If you decide you want to cut it to a 1/2 micron for your thickness, just cut the time in half.
So how, like on the solution here, when do we know we have to replace or replenish, or, I mean, would you just replace it when it stops plating, or?
There's kind of a guideline where if you're doing a 5-liter bath or bigger, it makes sense to replenish the bath. Generally, when you're working in 2-liter and 1-liter, it's better to use the bath up and dispose of it and put a new solution. GT4A, the thickness gold, you can replenish it. You would replenish the gold with potassium gold cyanide. Because this bath really is gold and cobalt, the only thing that would happen as the cobalt leaves the bath, and it leaves at a much lower rate, is you would begin to see a color variance. If you're not using this for your end color and you're flashing over, you can make a couple replenishments of gold before you would need to just change the bath out. My recommendation at that size, at 2 liters, use a solution till it stops working. The indications that you'll get when the bath has been depleted of precious metal is you'll begin to have a really thin layer of material. So let's say you're in there for 1 minute and you notice that part of it's plated and part of it's not.
Okay.
You've probably consumed the gold.
Gotcha.
You generally can plate this bath down to about 0.8 grams per liter before it would need to be thrown.
Okay.
The reason at 0.8 is because you can use this as a flash bath also.
Oh, okay.
You will get some coating at low concentration. But once you really drop below about 1.5 grams concentration, you lose the ability to build thickness.
Okay.
Okay. And the same with the gold flash, which is the GF3N. You really want to watch for the bath, making sure it's plating even, making sure that you don't see any areas that are not, you're having adhesion problem. That can be an indication that you're running low on metal. But really you'll see it because you'll see parts that are plating well and parts that are not.
Okay.
And you're seeing that bottom color. This bath is originally built at 0.8 grams per liter. If you're going in, remember, you're only using it as a color flash now.
Right. Yep.
So your maximum time in this bath could be 30 seconds.
Gotcha.
You're not doing anything to put down thickness because you're going to have a good contrast, I guess a bad contrast, between this and the thickness gold.
Oh, okay.
So that when it starts to rub off, the customer is not going to be able to see that.
Okay.
As you go through each step, you go to its designated rinse,
Okay.
and then you go into the next bath, and then designated rinse. Once I start plating, you'll see that I'm adjusting the voltage as I move because each bath has a specific voltage requirement. It's usually a really good idea to have a timer, just one of those little electric timers that your operator can have right here,
Okay.
and they can adjust it. I would recommend even 3 timers. So you have one designated here, here, and here,
Okay.
so that they don't have to reconfigure the timer. I generally use my watch, but in a production area or somewhere that you need to be really consistent and the operator doesn't, has other things going on, put a timer so they can hear it, so the part doesn't stay in the bath.
Okay. What, just one more quick question. On the solution, once it gets depleted and we have to change out, what do you do with the old solution?
It's really going to depend on regulations in that area.
Okay.
Generally, what I do is I save the bottles.
Okay.
I put the spent solution back in the bottle because I know it's a chemical resistant bottle.
Okay.
It's got a seal lid, seal it, and then I write on the outside consumed or ready for disposal. Most places have somewhere that you can take them. For example, here in Albuquerque, we have a place that's about 2 miles down the road where we can take our spent solutions and they'll dispose of them.
Is there
Now,
a fee here when you do that?
here it's free.
Okay.
They offer a free service where you can take it, and it's just because they want to make sure that nothing's getting into the water system, etc. Now, if you're disposing of 1 bottle every 6 months, it would take a really long time to collect enough solution to be worth refining,
Okay.
because that's the other option. The other option is you collect your spent solutions until you have enough that a local refiner can buy back the material that's inside from you. Generally, I would say that if you figured you were getting 50% back, would be on the high end.
Okay.
Most refiners, I don't know about down there, most refiners here have a minimum fee of $250 just to process it.
Okay.
So you have to have a good idea that you have enough metal in there by the time you pay the min $250 and then they charge whatever metal they're keeping, that it's going to be worth it.
Okay.
So that's an option. And a lot of people do that. They will save up in like a 5-gallon container for even 2 years their spent solutions.
Okay. I know that like some acids, I'm able to neutralize it with baking soda
Mhm.
and then just pour it down the drain. Is that a possibility, or is that not do that?
Again, it's really the regulations that are there.
Okay. Would the boric acid or the baking soda neutralize that at all?
I wouldn't recommend doing that
Okay.
and putting it down. And it's just because as you use the bath,
Yeah.
its concentrations change.
Okay.
So one thing that's important to note is as a bath goes down, what's evaporated off has been water.
Okay.
Okay? Your other components are not going to evaporate off. So you refill this bath with your DI rinse.
Okay.
So in the case that you've, because of heat and evaporation, that it's come down, you've increased the concentration of maybe cyanide, you've increased of acid.
Okay.
So refill that bath before you put it in storage with
Do you
DI
use
water.
that in the back to refill it with?
If you know you're going to dispose of it, you
Uh-huh.
can just you could use regular tap water because
Oh,
you know you're
okay.
disposing.
I gotcha.
If you're refilling your active bath
Yeah.
to keep using it, either use your recovery rinse, which is here.
Okay.
And the reason you would primarily do that is because you've drug in some metals and stuff that you can put back in the bath.
Okay.
If you're not going to use that, or you're worried that this is contaminated, use DI water to refill,
Okay.
making sure it's DI. You always want to use DI in the whole process.
And that stands for
Deionized water, or you can even use distilled water.
distilled water.
Yeah.
Okay.
Critical, even in the cleaning phase.
Mhm.
Make sure when you're mixing your degreaser and your neutralizer that you're mixing with DI or distilled water. Generally, we want the water that we use in this process to be less than 10 microsiemens, and that's measuring conductivity.
Okay.
And that's really the primary thing we're looking for because we're getting metals out of the water. So if you have a way to test that and they have little testers, I would recommend it because then you're able to keep track of
So
your
you have
water.
little testers to test water,
Mhm.
you're saying? Okay.
Yep. And I can show you one that I have before
And
you leave.
it's not a pH level though, right?
No, because really you're not going to maintain these baths, so monitoring the pH is not a big deal. You don't need to worry about that.
Right.
This is just to measure the purity of the water that you're using for your rinses
Okay.
and to build your degreaser and your neutralizer
Okay.
and to refill your baths.
Gotcha.
Okay, once we get going, we're going to move pretty quick down the line, and here's why. As you start plating and you get that surface wet, and you want to keep going because I mentioned earlier just in a conversation we had that the pH on the surface of the part is important.
Okay.
And what we don't want to have happen is that piece sit out here for a while and then become what we call passive.
Okay.
Okay, then we would have to reset the pH on that surface, reactivate that surface. So once we start going, we'll keep going.
Okay.
Drying a part at the end of the process is important. One of the things that you'll find, especially if you happen to get a thin layer on a copper part, you're going to get you could get what's called copper migration over time. And sometimes a wet surface will leave spotting on your parts. That's even over a gold part, okay? So it's important to recognize that even putting a fresh gold layer over the piece doesn't mean that that piece is completely protected.
Okay.
You want to get the water off, get it dry, and you want to make sure that you're putting enough layer on there that you're not going to get that copper migration over time, which is going to result in tarnish.
Gotcha.
Okay. So we've pre-fixtured these pieces. Generally, copper wire is fine. As I mentioned before, as you're going into a high acid bath, like rhodium, for example, you would want to pre-coat this wire
Okay.
and even the piece with something like palladium, for example, before rhodium, and that will keep the copper from dissolving into the acid bath and the rhodium bath and contaminating it.
Okay. And we can reuse the wires.
Absolutely.
And what gauge wire are you working with there?
Honestly, you could use anything from you could probably go down to even 22 gauge.
Okay.
Generally, anything more than that is not a requirement, but you get rigidity, and you're going to want that with some pieces.
So my other question would be, can it be too thick or too thin?
Mhm.
For mainly the plating process, not so much stability.
Sure. So if you have a wire that's too thin, you are not getting enough conductivity passing through that piece.
Okay.
And that can cause problems, especially in an area where you maybe have a jump ring or an ear wire,
Okay.
because you're needing to pass everything through a really thin wire, then pass it through some small contact points.
Okay.
So with a part like this, I intentionally picked a thicker wire.
Gotcha.
And that was because I wanted to make sure I was giving enough conductivity passing through.
Okay.
It is possible to go too thick
Okay.
with your wire. The main reason is you're wasting metal. The thicker that wire is, the more gold you're putting on that wire, the more rhodium you're putting on that wire.
Okay.
From a, its ability to carry the electricity and would it cause any problems in the part? Not so much, but it's just a waste of metal
Okay.
more than anything.
Gotcha.
Okay, so as we go through each one, I'll cover what the voltage should be and the time in that bath.
Okay.
So the first one we're going to do is degreasing.
All right.
Degreasing is going to be in a 2-liter bath the highest amperage that you'll pull.
Okay.
Okay. Keep in mind, plating is done at low voltage, high amperage. That's what it's considered, especially when you get into big and large plating factories.
Okay.
E-coating is the opposite. And I bring this up because I want people to understand. E-coating is done at high voltage and low amperage. The reason I bring that up is voltage is not what hurts. It's amperage. That's what hurts. Okay? So the reason I bring that up is because this bath is going to run at about 7 volts. Could pull anywhere from 5 to 7 amps. That means that wire is going to get hot. So you just want to, plus it's a heated bath. But really it's because of the amount of amps we're going to pull.
Okay.
As we go through the other baths, you're going to see something closer to 1 to 2 amps. But this bath specifically will pull closer to 5 to 7.
Okay.
And it's important that you pull that much. If your rectifier happens to restrict the amperage, you need to open the amperage all the way up. Okay? If you were cleaning at, let's say, 7 volts and you were only pulling 2 or 3 amps, that part will not get clean enough to be successful through the process.
Okay.
So when you get your rectifier and you get set up, open the amperage all the way up.
Okay.
Don't let the rectifier restrict that.
Gotcha.
Manage your process off voltage.
Okay.
Okay. So we'll get this one set at around 7 volts. Most rectifiers have a coarse and fine knob.
Oh, okay.
Okay, so you can make a quick jump and then fine tune.
Gotcha.
Now, before we start real quick,
Sure.
we'll run through exactly what each one's going to be.
Okay.
Okay, so if we go to the tech chart for the GT4A, we know we're going to run for 2 minutes. The next thing we're looking for is the voltage. And if we come across this line, we'll see that we want to be at 4 volts for 2 minutes.
Okay.
Okay? Then the next one we're going to do is going to be the Gold Flash, which is the GF3N. On the GF3N, we're going to come across here. Treatment time, 20 to 50 seconds is in the range. Optimum's 40. We're going to do 30 seconds because we're just flashing color over the top. Okay? And the voltage that we're going to run on that one is 3 volts.
Okay.
All right? Okay, so we're going to get started and we're going to go 1 minute in this bath. Now you'll notice that I put 2 pieces on this wire. It's important that your anode to part ratio almost always, with the exception of a few baths, is 2 to 1. You want more anode than part.
Okay.
Okay? So I easily have enough anode in here to cover probably even 4 of these.
Gotcha.
Okay? Once I place this on the cathode bar, it's going to automatically start to pull amperage and start plating. I don't need to do anything else with it except run the time. Okay? So we'll see we're up close to 5 amps. You can see the agitation, and that's what you should see in cleaning always. And we're going to time that one. Now, because we have the magnetic stir in there agitating the solution, we don't need to agitate the part.
Okay.
A lot of people plating that use a beaker maybe don't have that agitation, so they have to move the piece.
That's me.
There's a big advantage to this system. So actually I designed this system, and when I designed it, I wanted this system to replicate the advantages of a large plating house.
Okay.
One of the advantages to that is having a fixed distance from your piece to your anode. It doesn't change.
Gotcha.
When you're agitating the piece up and down,
Yep.
you can have a problem.
Yeah.
Because as you get close to that anode and further away, you
Mhm.
change what's depositing. You can change the color and the thickness.
Okay.
Okay. So now I'm going to use this only because I expect it to be hot. We're going to remove the piece. Now what we'll look for after we rinse is one of the biggest indicators that we got a good clean is the color of the wire. You can see how the wire is shiny
Yep.
down here, and it's not so much up here. That means we got a good clean.
Okay.
Okay. We're going to go from here to our neutralizer. I like to keep these covered. It is acid, so especially if there's going to be other people around. Again, we're only in here about 10 seconds. Then we're going to rinse. Again, a designated rinse for this one. Now usually what I'll do real quick is I'll come and set my rectifier before I bring that part out so that I can go in still wet, especially when we're talking copper. So this one we looked, and we're going to go 4 volts for 2 minutes. Okay. And the same thing. We're going to go directly to here, and we'll see you should get close to about 1 amp. If you ever feel like you're not getting enough amps, so that your conductivity is not good, you can always take and wet this connection point, and also just making sure that your anode is tight. You'll see the agitation in there. You don't want a lot of gassing.
Okay.
Okay? You want to see basically mild gassing, which are the bubbles you see coming off the part there.
And this one is for how long again?
2 minutes.
2 minutes again.
2 minutes for 1 micron.
Okay.
You may choose to do a half micron.
Okay.
Don't have to go that. That's just the efficiency of the bath is
Sure.
to build 1 micron.
Okay.
It's important to keep the machine clean. So all these connection points,
Mm-hmm.
over time, if you're leaving the baths in here, you'll start to see some corrosion build up.
Okay.
That'll show up as kind of a green corrosion similar to battery posts in a car, something like that. Keep those clean, because as that corrosion builds up, if your connection points are not great, you're killing its ability to send the proper voltage and get the
And
proper current.
How do you clean them?
These are really easy. You just take them apart.
Yep.
So this literally picks up and comes off.
Okay.
And you just unscrew it right here and take it, and you can clean it with a mild abrasive, and that's pretty much it.
Okay.
The good thing about the unit is it's corrosion resistant. That's one of the reasons we made it
Yeah. I like
in
that.
this material. All right, we're going to go about another 20 seconds.
And will you use the pliers again to lift this one out?
No, it won't be hot now, because now we're pulling a really low amperage in this bath, as
okay.
opposed to
So it
what
was
we were
the
pulling there.
amperage that made it
Yeah.
more. Okay.
When you pull 5, 6, 7 amps,
Gotcha.
that wire is going to have a lot of electric heat.
Yeah, okay. That makes sense.
All right. So now we're going to come out, and we'll see the thickness. This generally, again, it's gold cobalt, so it's going to have kind of a 24 color.
Yep.
Because there's no copper in this bath. Okay. Now we know we need to be at 3 volts. I can hang that there. And here we're only going to go for 30 seconds.
So you don't have to neutralize and rinse on this side?
No,
Okay.
not between this step. You don't have to. There's really no reason to. Some big factories do, and they have an entire rack.
Uh-huh.
But because we have fresh rinse water, we're working, there's no reason to.
Okay. is that 1 amp?
Yeah, it's 0.1 amps.
0.1,
Mhm.
okay. So very little.
Very low, and mainly that's because of the size of the part.
Okay.
When you get your 2-liter unit, your anodes are going to fit tighter in here.
Okay.
Okay, the 1-liter, these are 2-liter anodes in this 1-liter unit right now.
My video stopped, but that's okay. I got this other camera going.
Okay.
I have to clear off my card.
All right.
Wow. That's crazy.
Now you can, after this last step, if you want to hit it with the neutralizer and rinse, it just makes sure you kill anything that's in any recessed areas,
Okay.
so you don't get a reaction.
Okay. And then you say to dry off?
Yeah, and generally all that is, you can just take a paper towel, something really, you know, that's not too abrasive.
Wow,
I'm not
our
sure what
wire's
the wire
plated.
was, but it plated fine.
Yeah.
I almost wonder if it was silver, because it was kind of tarnished.
Oh, okay. Let me just go unload this video.
Now, one of the best ways
Mm-hmm.
to tell how good your plating is working,
Yeah.
believe it or not, is not your pieces,
Oh,
because
your wire.
your wire.
Wow.
Because a lot of times your pieces have a matte finish to them anyway.
Uh-huh.
So you'll get a matte finish like that, which is exactly what we were looking for. But if you want to know, is my solution going on without burning the part, you always check your wire.
Okay.
If for some reason the voltage was too high or something was going on in the bath, you would see it on the wire. This wire's perfect.
Okay.
So teach your operators to use the wire. That's their indicator. How's my
Okay.
plating going?
Cool. All right, give me about 5 minutes.
Yeah,
and
no problem.
do this.
Yeah, came out good.